In this video, we're going to look at how we can find the equation of a line when we are not given a graphical representation or a diagram of the line itself. So we're just going to be given bits of information. So we're maybe given the gradient of a line and a point. We're maybe given 2 points which it passes through, or maybe given a point it passes through, and also told that it is parallel to a certain line. In this example A, it says, find the equation of a line which has a gradient of 4 and passes through 0, 6. So we're going to do these all the same way if we can, and that's by using the general equation of our straight line, y equals mx plus c. Now we're going to read the question and see what information they have given us. They've told us it has a gradient of 4. So that means m is equal to 4. Remember, y equals mx plus c is the general equation of a straight line which has a gradient m and a y-intercept of c. Right, they've actually told us the intercept here, 0, 6, it passes through 0, 6. 0, 6 is on the y-axis, so that means c is equal to 6. So this bit of working out I'm doing in this one, really you could bypass this, but just to show you, because this method I'm going to do now, this works for all examples. So what we're going to do is sub in. So first of all, once we find our m is equal to 4, then we're going to rewrite our equation. So y equals 4x plus c. So this is the equation we're going to work with now. Okay, y equals 4x plus c. Now what we're going to do is sub in the point 0, 6. So 0, 6 means when x equals 0, y equals 6. So instead of writing y, you're going to write 6. Instead of writing x, you're going to write 0. Now the reason I've shown you this one, as I said, we could have really just fired in 6 as our c, because that was our intercept, is this bit here, 4 times 0 is a very, very common mistake that even very good people make. A very silly mistake. 4 times 0, 0 times anything is just 0, so that really is just 6 is equal to 0 plus c, which means your c is just equal to 6. Now what you need to do, you've now found your gradient and you've found your intercept. Rewrite the equation. Rewrite your equation as y is equal to 4x plus 6, and that is your final answer. Example B, it says, find the equation of a line which has a gradient of 2 and passes through 3, 4. So the same thing we're going to do here. I'm going to write down y equals mx plus c, your general equation of a straight line, and read the question. It tells you it has a gradient of 2. So straight away you have found your m is equal to 2. So rewrite your equation. Instead of m, write it as 2. So y equals 2x plus c. And then what we want to do, same as the last question, we want to sub in the point which is 3, 4. So subbing in means you're going to replace your x value with 3 and your y value with 4. So your y value, instead of y equals 2x plus c, it becomes 4 equals 2 upon 3 plus c. And then just take care. 4 then is equal to 2 times 3 is 6 plus c, and then that 6 goes across. 4 minus 6 is equal to c, which means your c is equal to minus 2. So we'll rewrite the equation, your final answer, y is equal to 2x minus 2. And that is your final answer. That's your equation of your line, which has a gradient of 2 and passes through 3, 4. Okay, example C says, find the equation of a line which has a gradient of minus 1 and passes through minus 2, 1. So again, write down your general equation of your line, y equals mx plus c, and your m is equal to minus 1. So you can write it as y is equal to minus 1x, which is just minus x plus c. What you then want to do is sub in the point which is minus 2, 1. Which means y is equal to 1 and your x is minus 2. So that's what you have. So 1 is equal to minus of minus 2 is just plus 2 plus c. And 1 minus 2 is equal to c, which means your c is equal to minus 1. So your last line, rewrite your equation. It's y is equal to minus x minus 1. That's all we're looking for. Okay, the next example says find the equation of a line which passes through 4, 15 and minus 1, 5. So this is considerably more difficult, this example. So I'll maybe give you an extra one of these. To do this one, again, write down your general equation, y is equal to mx plus c. Now read the question, and what it doesn't tell you for the first time, it doesn't tell you the m, it doesn't tell you the gradient. So you've got to find the gradient. So we're going to use the fact that the gradient m is equal to the y difference over the x difference. So the y difference in this case, I'm going to start with this coordinate. So my y value of it is 15, and then my y value of this one is 5. So 15 minus 5. Remember, I'm starting with this coordinate here. So my x value of this is 4, and my x value of the other one is, and careful, minus 1. So what you've got is top line, tally up, 15 minus 5 is 10. And the bottom line, 4 minus 1 is the same as 4 plus 1, which is 5. And 10 divided by 5 is 2. So rewrite your equation. Y is equal to 2x plus c. So y equals 2x plus c is your equation. Now what we can do is sub in either of these 2 points. So I'm going to sub in 4, 15, just because it doesn't have any minuses. It might be a wee bit easier for me. So my y value is 15. My x value is 4. So it's 2 times 4 plus c. So that's 15. 2 times 4 is 8. And then plus c. And then 15 minus 8 is equal to c. So your c works out to be 7. So rewrite your equation. Y is equal to 2x plus 7. Y equals 2x plus 7 is your final answer. Okay, so a bit trickier that example. It says y is equal to, find the equation which passes through 4, 15 and minus 1, 5. So why it was trickier was they didn't give you their gradient, so you had to use the fact that the gradient is y difference over x difference to find it. Okay, this is a bonus one here of this type. So you're to find the equation of a line which passes through minus 5, minus 6, and minus 9, 6. So let's just divide this one up. And again, you're going to write down your y equals mx plus c. So I'm just going to say my m in this case, again, just like your last one, is your y difference over your x difference. So your y difference over your x difference. So your m in this case, I'm going to start with this one. So my m is minus 6, and then minus 6. That's my y difference, because I started minus 6, minus 6, and then I'm starting with this one again. So it's going to be, my x value is minus 5, then minus 9. So let's tidy that all up. What we have is minus 12 on the top line. On the bottom line, you have minus 5 plus 9. Minus 5 plus 9 would be plus 4. And minus 12 divided by 4 will be minus 3. So from here, you're going to rewrite this as y is equal to minus 3x plus c. Then we're going to sub in one of the points. They are both not particularly nice, so I'm just going to sub in the first one, minus 5, minus 6. So that means my y value is minus 6, my x value is minus 5, and then plus your c. So that's minus 6 is equal to minus 3 times 5 is plus 15 plus c. And minus 6 minus 15 would be equal to your c, which is minus 21 is your c. So your final answer, y is equal to minus 3x minus 21, and that is us done. So that's probably the hardest type of example you can get. Okay, last example, it really refers back to your previous video, which was on parallel lines. So it says find the equation of a line which is parallel to y equals 7x plus 6 and passes through 1, 1. Again, write down the general equation of our line, y equals mx plus c. If our line is parallel to this one, then it has the same gradient. So the gradient of y equals 7x plus 6 is 7. So y equals m equals 7. So what we know already is our line is y is equal to 7x plus c. What we must do then is sub in the point which is 1, 1. So 1 is equal to 7 times 1 plus c. So 1 is equal to 7 plus c, which means, I'll go over here and finish this off, 1 minus 7 is equal to c, which means your c is equal to minus 6. And your last line, rewrite your equation, y is equal to 7x minus 6, and give a wee tick. That is correct. Okay, so you now know, from this video, you know now how to find the equation of a line, general equation of a line, or equation of a line which passes through 2 points, or which you know its gradient and you know what passes through a point, or in the last example here, you know it's parallel, what line it is parallel to, and you know a point which it passes through.